So, hello everyone. I'm Srijai, and in this session, we'll be covering Unit 1 and 2 of your computer organization and architecture. Right. So, as far as this Unit 1 is concerned, it's a very simple unit. So, we'll just go through the slides once and just learn and just skim through the topics as far as Unit 1 is concerned. In Unit 2, we'll go into the details of the topics. Okay. So, this will be a recorded session since I feel like I need to nail the delivery a bit more. So this is going to be a recorded session, and if you have any doubts, feel free to contact me or in the group WhatsApp group. Right. So yeah, guys, let's start. So this is going to be the syllabus from function all these stuff. We'll go to the actual stuff. Okay. So yeah. First, functional units. So, as far as when it comes to any computer, we need these basic components to survive. What are they? Input unit, output unit, CPU, which in turn contains two parts components called arithmetic logic unit and control unit, and then a memory to support the process. Support complement the process, and then a bus structure for communication between all these functional units. Okay. So yeah, I think it's way better in these, in this diagram. Okay, so in this, the instruction sets are given to the central processing. This instruction sets are given to the central processing unit, right? So central processing unit contains a set of components, such as cache memory, operational registers, inside operation registers, we have program counter, and then a logic unit, and then a control unit. So we'll be learning all about these in detail in subsequent slides, right? So what happens is basically there'll be this processing unit, and then please excuse me, get the point of what I'm trying to say, right? A memory system and then an input output system. So there is this constant interaction between the input output functions and the processes, processor, right? So what happens? These instruction sets are given to the CPU, the processing unit, which will in turn get its data and addresses. And just a normal definition. What is computer? Computer is a sophisticated electronic calculating machine that accepts input. Basically, what we saw in the last slide, right? Input, process, and process and memory comes here in this point, and then produces the resulting output information. Again, which is input output. Okay, technically this should be output. This should be input. This should be input, and this should be output. Right. So yeah. And this is nothing. Functions performed by a computer are accepting information to be processed as the unit, storing a list of instructions to process the information, and processing the information according to the list of instructions, and providing results as an output. Right? There is nothing for me to explain here. So yeah. Uh, as far as functions is concerned, in every type of functions which is there can be put into these four categories, right? Data processing, data storage, data movement, and control. Okay, so what is the unit? See, what is data? Data is a unit of unit. Is an sorry, data is a unit of information which is manipulated by the process and functioning units to perform the necessary operations, right? So the data can be either processed, or data can be stored, or data can be moved across the different components of the computer, or and apart from that, we can also control the information, how the information is used, right? So yeah, next, functions and functional unit. The operations performed by a computer using the function units can be summarized as follows. It accepts information through input unit and transfers it to memory. Information stored in the memory is fetched under program control. place inside the computer. So see, this is basically the thing which we saw here. Okay, so I don't think so there's this things for me to explain here. Okay, so this is sort of important. I mean, not important. I mean, better if you could remember these. No, not important. Maybe not misleading. It's over. It's not necessarily. I wouldn't say it's important, but it's fine to just remember these. Okay. So as I said before, it's they have input and a processor and a memory to access memory for the tab and to access stuff. So yeah, input unit. What does input unit do? Input unit accepts information like via human operators or through electromechanical devices and through or either through other computers as well. Output unit sends the results of processing. It will receive the process information and it will send it outside, either to monitor display or some kind of display mechanism. It could either be a physical, it could either be a digital version or a physical version printer. Next, ALU. This is the thing which performs the decide operations on the input and based on the instruction on the memory and gives the processed information. Okay. Next, control unit. Control unit coordinates various actions such as input, output, and processing. So this is the one which takes care of everything. This control unit is the one which takes care of everything happening here. Okay. So that's it. Yeah, that's it, I guess here. Okay. I'm sorry for the last recording. I didn't notice that there was some issue with my audio quality. I hope it's better now. So yeah, where was I? I think yeah, I have finished it. Yeah, right. So next, information in a computer. So instructions are the commands which make the computer functions work, right? So instruction, like let's see, instruction specify commands to transfer information within the computer, transfer of information between the computer and IO devices, and perform arithmetic and logic operations. So basically, we noticed that we saw that there are components in a computer which take care of input, output, memory, and processing, right? So, instructions are the command which enable a dialogue between everything and everything else, right? So yeah. So this what instructions are the things which help these things to happen. These things to happen. Okay. In fact, these are instructions. I mean, sorry, that would be put it that way, right? So these are the ones which transfer information within the computer. Within the computer. Okay. Let me put it. No, you see, I don't need to write it down. Like, instructions are a command which help to transfer information within the computer as well as between the computer and the IO devices, as well as perform the large arithmetic logic operation inside the processing unit. Right? Whereas when there is a line of instructions which are related to one another, and performed one after the other, those are called as program. Okay, and those are stored in the memory. Okay, the processor fetches instructions that make up the program from the memory and performs the operations stated in those instructions. So the process, what does processor do? It takes the program from the memory, it fetches the program from the memory, and then it performs the operation mentioned in the instructions one by one. Okay, and goes to the entire program. So that's what is happening. Right. Next, information in computer. Yeah, so data. Data is the thing which the instructions operate on. So data is the static things, static components in the computer, which are it could be numbers or encoded characters. Basically, yeah, it's given here. Data in a broad sense means any digital information. So the digital information is present in the computer, and instructions are the things which are used to operate on it. Okay, instruction are the dynamic component, dynamic things which are working on the static things which are data, right? So yeah, in computers we represent data as an encoded string of bits, binary digits. I mean, sorry, data is represented as an encoded string of binary digits. So by combining binary and this thing ATS, we call it as bits, not to make it easier to for us to go through that. Okay. Next, input unit. Okay. So this is the computer. Uh, Input unit works here, right? Okay. So input unit is that input unit gives the information, gets the information from the environment and gives it to the processing unit inside. Okay, in a specific format in which the processing unit will understand. Okay, so the tasks that are performed by the input unit are interfacing with the input. What? Sorry, yeah. Basically, input devices are interface of input devices makes the input unit, right? So what it does, it accepts binary information from the input devices and presents this as a binary information in the format expected by the computer, right? And then after presenting it, after converting it into a form which the computer understands, it transfers this information to the memory or the processor, right? So that's what happens. Okay. Yeah, so this is the example. This is an environment. The input unit gets the interfaces with the input devices and gets the signals from them and converts it to a binary information which is understood by the computer. And then it gives it to memory as well as and if it, actions for the PAC. The input taken in directly goes to memory, but also by processor. The thing is, there are some processes which require real-time application and real-time processing of the input given. Right? Like what to say? Yeah, see, there are some functions which require immediate real-time updates, right? So for that, we give a connection between the input unit and the processor. Okay. So yeah. Okay, guys. There seemed to be an issue. I mean, the issue with the mic seemed to be persisting for a long time. So I'll change the mic. I hope the audio quality will be better now. Okay. So yeah, okay, let's talk about memory unit. So what is memory unit? Memory unit is the thing which stores the instruction and the data, right? So we saw that data is represented as series of bits and instructions are the one which are used to work upon on the data, right? So the memory unit is the one which stores both of these together. Okay, I mean together in a sense, not exactly together, but like you get the point. Both of them are in the memory unit, right? So processor reads a set of instructions and reads the data. I mean gets the data, writes the data from a to memory during the execution of the program, right? What is there to say in this? Yeah. So a group of bits stored or retrieved at a time is termed as a word, and the number of bits in a word is termed as a word length or a word length of a computer. Okay. Basically, yeah, when you bring in a set of bits together, these form a set of characters. I mean, these individual characters set to form a word, right? So that's what it is. And the number of bits that could be taken in the same time from the processor, I mean, from or to the memory is called as word length. Okay. So, yeah. Yeah. So this data is present in the memory, right? So they are stored in memory. There needs to be a way. There needs to be a way for in which they will be accessed by the processor, right? So how does it do? That's where the address comes into play. Okay. So address is associated with each word location, and processor will access the. Will give the address to the. With the help of address, the processor will access the memory which is inside, the data present in the memory, right? So that's that. And then memory unit. Processor writes to or from memory based on the memory address. So it accesses any word location in a short and fixed amount of time based on the address. And random access memory provides fixed access time independent of the location of the word. Access time is known as memory access time. So yeah. All right. Representatives. Yeah. So see, basically, processor is. This is a known sentence, right? So the random access memory provides fixed access time independent of the location of the word. Okay. So what it does is there is no, order in which these are stored. These memory bits are stored, right? So there is no time difference between the access accessing of one word with the other. So that's what random access memory is all about. And the time taken to access the data present inside the memory is called as memory access time. This might be an important one mark. There was an important one mark. So if your paper has 1 marks, this is a very probable question. Okay. Yeah. So memory and processor have to communicate with each other in order to read write information. In order to reduce communication time, uh, a small amount of RAM is tightly coupled with the processor. So yeah, so basically what happens is random access time is something which gives a fixed access time, right? But there are some information data bits which are required more by the processor than the others, right? So what we do is, what the computer does is, uh, these relevant information, relevant and frequently used information uh, from the RAM is kept is kept in a thing called cache, okay, which is tightly coupled with the processor. So the access time in cache is much lesser than the access time in the I mean the access time required to take data from the RAM. Okay, so modern computers have 3 to 4 levels of RAM units with different speeds and sizes, right? So the smallest is cache and the largest is the main memory. Okay, so yeah, primary storage. What else? What else? What else? Yeah, there's nothing here. No. Primary storage. Primary storage of a unit consists of RAM units. Primary storage is insufficient to store large amount of primary data and programs. Okay, so this is the cache which we talked about. It is tightly coupled with the processor. Wait, what? Yeah, yeah, and it is tightly coupled with. No. Sorry, apologies. Right, my apologies. So there are two types of main primary unit. Primary unit is the one which is present inside the computer. Second units are the one which are present outside the computer. Right. So yeah, primary units can be added, but it's expensive. Okay, whereas secondary units is just like say pen drive or magnetic disc tapes or CD-ROMs, and the access time is lower, but the cost is less. Right, and the cost of a memory unit it depends on its access time. uh, yeah, so it is inversely related. So lesser the access time, in order to get a faster access time, you obviously need it to be closer with the processor, which will in turn increase the cost of the entire thing, right? So yeah, that's that. Yeah, so arithmetic and logic unit operations are, so yeah, this is the one which performs the operations with the with the help of memory and with the help of data and the instruction. Okay, so at, at the core, what they perform is arithmetic operations and logic operations. So what is arithmetic operation, what is considered as an arithmetic operation? Things like addition, subtraction and stuff. And logic operations are comparison of numbers like greater than, smaller than, equal to, all the stuff. Okay, in order to execute an instruction, operands need to be brought into the ALU from the memory. Yeah, obviously, in order to perform the instruction on the data, we need to bring the the operands from the ALU, from the memory to the ALU, right? So yeah, operands are stored in general purpose register available in the ALU. Access time of general purpose registers are faster than the cache. Yeah, obviously, registers are the ones, present inside. Forget about processors. It is present directly inside the arithmetic and logic unit itself. So obviously, it's way faster than even more faster than the cache. Okay, and the results of the operations are stored back in the memory or retained in the processor for immediate use. So yeah, what else is there? Output unit. Yeah, so output unit represents the process information from the thing from the processor, and displace it outside the outside displace it to the outside environment. Right, yeah, and that's the exact opposite of what the input unit does. So output unit interfaces with the output devices, and it takes in the process results provided by the computer in the language it understands, and output unit will convert the binary form into the form required, and then give it out to the real world. So that's what happens. There's nothing much here. Yeah. So all the input, output, memory, ALU, all these stuff, the processes of the operations of all these stuff are controlled by the control unit. So instructions control what operations takes place, and control unit generates timing signals, which this determines when a particular object will take place. So operation takes place, right? So control unit tells, I mean, control unit will generate the time signal, and everything in the computer works according based on the timing signals, right? So yeah, that's it. Control unit. So yeah, what does control unit have? Control unit works with a reference signal called the processor clock. Yeah, so this is what I mentioned. It is a clock for the particular computer, and everything in the computer works based on the timings in the based on the clock, uh, based on this particular clock, right? So basically, the processor will divide the and let's say there's a big operation right there, okay, happening. It's supposed to be happening, and it's taking these many steps, okay. So what processor does is it divides the operations into basic steps, right? Like one, two, three, four, five, okay, and it will make sure that this step is executed in one clock cycle. This step is executed in one clock cycle, and so on, right? So that's what it is. Yeah, what else is there? Yeah, so this is an example. For example, if we have an instruction add R1 R2, so what we'll do is this T1 is this thing. No, where is this? Yeah, this is the timing signal one. I mean the yeah, okay. So what it does is T1 will enable R1 and T2 will enable R2, and in the time 3 ALU is enabled for addition operation, and then a last time signal. I mean, sorry, time cycle. All the uh, things are processed and stored. The result is stored on the memory, right? So that's that. Okay. So yeah, I mean these are pretty easy topics, so I'll get through them fast. I won't be explaining much here because there actually isn't much to explain here. So yeah, where were we? We are at bus structure. Okay. So bus structures are the ones which connect the CPU and which basically connect any two components inside the computer basically. So but especially it connects CPU and the memory. Okay. And there are three types of connections. Okay. Those are data bus, address bus, and control bus. Okay. The bus structure is basically a group of wire which carries information from the CPU to the other components and vice versa. Okay. There are many types of bus structures. One of them is single. The first one is single bus structure. So in single bus structure, there is a common bus through which everything travels from one component to other. Okay. So input, memory, processor, output, everything is in a single bus. Okay. Uh, so input goes from here to either year or year, and when processor requires stuff, it sends a signal here and then it receives the memory here, and the same stuff happens, okay. So everything goes through a single bus structure. So what are the drawbacks of the single bus structure? So the devices connected to a bus, I mean, different devices have very different possible speeds of operation, right? So when there is a slow device, that will become the bottleneck of the uh, you know the entire bus structure. Okay, so there is a need for an efficient transfer mechanism to cope up with this problem. Okay, so what do you do? What is a common mitigation technique used here? It is to use buffer registers with the devices to hold the information during the transfers. Okay. Basically, what we do is we use buffer registers along with the devices to hold information and until the bus is free again to move without any trouble. Right. Another approach is the next bus structure we will be seeing, which is two bus structure. So in this, one bus can be used to fetch instruction, and the other can be used to fetch data. Okay. So basically we're splitting the entire bus structure into two. Okay, so one is used for instruction, one is used for instruction, and another one is used for data, right? So data, so that we split the weightage into two equal halves, that's reducing workload on the each bus structure. Okay. So the next one is the multi-bus structure. So here, I mean, again, as the name suggests, we use as many bus structures as possible to reduce the workload on each bus structure and to improve the performance as well. Okay. So yeah, basically we have control bus, address bus, and data bus, and I mean main types of bus. In that we have a lot of address bus, a lot of control bus, a lot of data bus, right? I mean, no, sorry. Control bus will be a single one, which will since it will be one which is controlling everything. Data bus and address bus will be more than one. Okay. Some of the bus functionalities in the multi-bus structure are in order to say, I mean, let's say there's an no wait. Let's say in the memory location, and this is a computer. I mean, this is a processor. Okay, so this is a processor, and this is the memory. Okay, so we told that we use address to send in to locate the required data, right? So there's a discrete amount of requirements for the memory locations to be accessed, right? So what we do is we use bus lanes. Okay, so what we do is the memory locations are represented as bits in itself are represented as bits. Okay, and to find out which memory location required, we use the the binary representation to access the resource. Okay, so because of through that, let's say we have 8 memory locations here. Okay, like 1 2 3 4 5 6 7 8. Okay, so in order to represent that, there's only requirement for 2 power 3, which is three lines, address lines to represent. I mean, three address lines to represent 8 memory locations, right? And yeah, in general, it's 2 power x. Okay, if you know we need to represent 2 power n bits, then I mean, we need to represent 2 power n memory locations. We use x bits to represent it, right? And then and these are the types. Okay, there's address bus, there's data bus, and there's control bus. So address bus is unidirectional because obviously it's the only requirement is address bus and takes information address from the process and gives it to memory for it to go and search inside the library of information and give it back to the processor. So where does it give it back to? The database. That database is bidirectional because remember it can also be input and output in there, right? And yeah, I mean, wait. This is not from. I mean, database is from processor to peripherals. Okay. Mm, okay. So yeah, and control bus is the one which controls signal from the processor to peripherals and vice versa, right? And it's bidirectional. And yeah, this is the diagram which is there, and I think you can refer it up. Okay, so yeah. Mm, 1 second. Okay, so yeah, next memory location and the addresses. So memory consists of many millions of storage cells, each of which can store 1 bit. Data is usually accessed by n bit groups. 1 second, wait a second.